Hello and welcome to my lecture review for the textbook, Internet and Web Application Security, 3rd edition. This is done by Jones and Bartlett Learning. Again, copyright, they own everything. This is their book. I'm using their PowerPoints. I'm just providing video lectures for my courses that are using their official book. The assumption is you own the book and you are in one of my assigned courses. The book ISBN number 9781284206166. Again, copyright for the Internet and Web Application Security 3rd edition by Jones and Bartlett Learning is owned and maintained by them. These are just video lectures on their official PowerPoints, so let's jump on in. Chapter 12, Testing and Quality Assurance for Websites. Here we're looking at analyzing the role and importance of website compliance and testing. Key concepts are going to be things like the software development methodologies, the testing cycles, testing strategies for websites and web apps, how to detect and mitigate security vulnerabilities as well as flaws in the websites and web apps, and launching a website and monitoring and analyzing traffic use, access, and malicious potential for malicious abuse. So, we're mainly focusing on compliance and testing for this module. First key area is the software development methodologies. So these are made up of interrelated phases or steps that will embody the life cycle or the development life cycle for the development process. These cycles represent a level that the development should go through, often known as the development phases of a project. And they'll pass through multiple phases, sometimes repeating some phases, and sometimes spending more time in other areas. All of this allows for the development and the completion as well as implementation of software. So software development methodologies approaches for managing and tracking software projects are typically like the SDLC, also known as a waterfall. We also have things like Agile or joint application development or just general DevOps. So these are not an exhaustive list of methodologies, they're just some of them. So we've discussed SDLC in other chapters, but part of the process is working through it. So the SDLC is a development lifecycle of 6 phases, from initialization to its full deployment, maintenance, and overall process of getting it out. The nice thing is there's a structured and phased approach that helps keep the project scope and focus for completeness, for performance, for security, for eliminating scope creep. Again, each phase is completed and approved before the next phase begins. So when we're looking at this, we're looking at the requirement analysis phase. This is also referred to the requirement gathering phase. It will detail requirements of their proposed application or website. They're collected from the stakeholders, the SMEs, and the end users. After that, we have our design. This will be identified requirements are analyzed to allow development team to choose programming languages that will best suit the need for the app, which database management system or approaches to use, if any, hardware modifications or additions that are needed, staffing for the development team or security team. It will define the conceptual and logical, as well as outline data flow designs for the app and developers and allow us to approve it in sequence. Third would be coding, and this will work with the designers to produce in preceding phases the programming portion to be completed. It will do design flaws that require alterations to the design phase. This may cause repetition of one or more prior phases for formal documentation, and it'll be going through over and over. After the coding phase is complete, then we'll get to the testing phase. The testing phase will be the completed program is tested to verify that 1. The programming performs the required functions successfully, and 2. Intentionally bad data does not cause the program to fail. After testing, that's basic quality checking, we'll get the deployment phase. And this is where the application or web app or website is placed into a production environment and made available to users only if testing has been completed and successful. After that, we have our maintenance phase. Minor issues may pop up as users start stressing the app or program or website in the real world. So this is where things might be tweaked and modified and whatnot. Changes in business operations or operations for state, federal, local law might change its management philosophy, requiring the app to change. Small fixes or adjustments or any of the normal maintenance could also be happening here. And this should also require changes that will force the application to be moved past its original scope. So a new development project might be in order. So this might go in multiple phases. This might go in a circular fashion. It really just depends. But this is the general SDLC process. The nice thing is when looking at the SDLC is it's more like a waterfall model. And they're best used when the following conditions are pre-existing. The requirements of the app are well defined, clear, compact, and concise. No scope creep. The operating environment is stable and the need for newer tech is pretty minimal. The required staff is available and has the appropriate training, and we're not having to worry about outsourcing. The time required for the project is typically short and can be able to get in and get done. So again, this is one of many methods. Another method would be the Agile software development method, and this is one of the processes that can be used with Agile development. The methodology, basically the team will tend to favor because it provides more identification of issues earlier in the project and does create a stronger collaboration interaction between the team and team members. Again, this is one of those easy iterations where it's a circular environment. The Scrum elements is basically a project which will be based on a user story, is assigned to a Scrum team as a sprint, and the sprint can take a while, a week, 2 weeks, 4 weeks, and it works through the process. So the participants would be like the stakeholders, the owner, the teams. The artifacts will be like the user stories, the product backlogging, the sprint backlog, things like that. The main concepts are the velocity, how well we're getting through it, and the done function. The ritual will be the actual components, the sprinting, this planning, the daily scrum, the sprint demo, and again, working through the cycle. Criteria for the Scrum method for the Agile project will be the requirements that are not clearly defined, changes that are going to be likely, minimal viable product, and then what are the open to changes. So here we have our input, work in progress, and output, and we can kind of go through the phases to see what's going on. Is less a software development methodology and more a visual workflow for management methodology. It will open and pending tasks on the board should show the status and the schedule. The objective here is to minimize lead time, improving workflow where necessary, and manage the environment. That way you can kind of see what's going on and you can see the overall arching portion of the project. Other agile deployment methodologies could be Crystal or the DSDM. The Crystal allows the development team to kind of more customize how they wish to collaborate based on the resources, the team members, the skills, the projects. It just is a little bit more process adjustable, also workflow adjustable. And the approval cycles do fit the needs of most organizations and projects, but not always. So for Crystal, you need to make sure that this is a good fit. Dynamic System Development Methods, DSDM, will focus on the goals of the project and the impact of the outcome on the business and the operation. It does rely heavily on governance. It's more incremental, yet its initiative approach in which end users or the owner feedback is key to the continual and the continuity of the project. It is more commonly used in much larger organizations and much globally diverse areas. So this is not going to be used by small organizations, so that is a pro and a con. Some other options are the extreme programming, or XP. This is a agile-based method commonly used for smaller orgs, and they have all their resources in a single location. They will emphasize 5 key principles: communication, simplicity, courage, feedback, and respect. And their developers participate in paired programming, in which developers work in pairs to create the program. After that, we have our future-driven development, and that will focus on the end user and the prioritization of user stories, which will produce the user's most desirable features first. They prioritize what's important and then what is less important. Each feature produced separately in their own priority sequences, and they're often used by organizations with fixed hierarchy structure to keep things organized. After that, we have things like the Learn Software Development, or LSD. This minimizes time to release for software development while maximizing quality and reducing the waste of time and resources. This lean version I've had some success with, but not one of my more in-depth agile methods. We also have our RAD. This is an agile framework that will use prototyping of software solutions and interfacing with the stakeholders and end users for feedback to build towards the appropriate outcome. It will be needed adjustments throughout, and you make them through the prototype, and then the cycle repeats until an acceptable section is gained. We also have our Joint Application Development, our JAD. This is commonly used in earlier stages of agile-based frameworks to learn and verify the elements of a user story. The user story is essentially requirements, their likes, their wants, things like that. This will speed up the identification and validation of epic details of a software solution or website by involving the owner or the end users and team members. This allows the development team to quickly and accurately translate the needs into the requirements of the product. So here we have our 5 steps: user story, design, development, testing, deployment. And between the user story and testing, we can cycle through this a few times before we get to actual deployment. The JAD team will be like a sponsor, a facilitator, a recorder, advisor, observer, things like that. The sessions and workshops are essentially the beginning or the initiation portion of where the ideas and suggestions that may be provided for the best solution for that user story. That's where this starts. In a workshop, the executive sponsor and other key decision makers will hear questions and discussion points from the different session stakeholders, and they make their decision to kind of figure out the pathway to move forward. Other methodologies could be things like our DevOps, and that's the acronym for Software Development and IT Operations, DevOps. So this will combine organizational software development and IT operational resources into one team that will work in parallel and collaboratively throughout the development process to aid in the development of a software solution. The goal here is to break down the roadblocks that exist between legacy approaches to software development and IT operations, and it's putting both groups together. So in this example, we have culture, automation, measurement, and sharing. The philosophy built here is the CAMS model: culture, automation, measurement, and sharing. These are the key principles of DevOps. The model can be viewed more as a pyramid. Culture, being the base, defines the requirements of the following characteristics of the organization. It should help create a collaborative work environment, eliminate assignments of blame, empower organizational-wide responsibility, motivate continual improvement, automate continual improvement and continuing development, prioritize the needs of customers and clients, learning from failure, and combining expertise. The next stage would be automation. That's related to frequently applied repetitive and manual tasks that are performed to their completion without needing any person or human assistance. Next would be reducing the development lifecycle, human error, and the size of the development team. After that, we have our measurement. This will refer to the section for capturing and analyzing of performance and effective data. This will include business operations data, metrics from software development life cycles, and things like that. Universal standards that are used are going to be things like recovery time, or the mean time for recovery, mean time for failure, and the recovery time objective, along with other areas. At the top of the pyramid is sharing, and this is where members share ideas, data, and results. The requirement of continual improvement requires the input of shared data and information from all groups. A lot of this goes back to multiple cycles, multiple methodologies, but the testing component's always going to be there. So whether it's an application or a website, whatever the case may be, the big thing is going to be testing. So the next section is about website testing. And a website, viewers will make a decision to stay or leave within a few seconds. If the visitor stays on the site, focus on the website will shift to the content and the function. But to keep the visitor on the site, how it looks and how that hook is there needs to work with an anchor. So asking a person who is not on the development team to look at landing pages or websites for a form for testing is going to be important. Launching a website and tracking its hits, and its use is part of the testing. In many websites or software development methodologies, this is going to be critical because of the time constraints. Testing may be limited to ensure that the site prescribes the function, works as designed, but if it's not appeasing, then you may miss your mark. And a huge part of that is the first impression. So the website stickiness, the ability for a website to hold someone's view. It starts with the first impression, and it's a 5-second test basically. This will measure what the user's first impression is after viewing the website for about 5 seconds, what information, if any, the visitor takes away from the site. Commonly used for testing for first impressions, and intended messaging is passed to the visitors. Actual length of the test may be relative, but no more than 15-ish seconds. The test viewers will open and view a website for an established period of time, and then they're asked questions. The results of the test should provide you with answers to questions like, what did the visitors see? Are they able to identify sections or objects that drew their attention? What did the visitor remember? Helps identify headers, links, or images that were there, and how they may have been interpreted. What did the visitor believe was the focus of the site? This will identify how well the site conveys the visitor message. Can they see, can they gain, can they purchase, can they learn from the site? What is the focus? And then again, a one-word descriptor based off the visitor's use. So what would be the sum of the first impression of that user? After first impressions, we have our functional tests. And that is another major objective, that you have to prove that it performs whatever tasks you said were important. It interfaces with other software or files or database systems, navigates as specified, and it flows according to the design documentation, that it works. So depending on the purpose and the scope of the site, testing should be planned. You should include test zones that exercise and stress each of the separate functionality. You should have a structured test and an unstructured test. If you only do a structured test, you may not get the impact if it did something random or if a user did something unexpected. Hence why you do unexpected unstructured tests. But you also need to make sure that if you do the same tasks repeatedly, that it gives you the same results. Smaller websites may not require all of the testing that a larger website may do. If you have 1 or 2 pages, you may not have nearly the same need as a site that has, 40 pages. Standard elements of website functionality testing should test the following areas: links, forms, cookies, HTML, security, documentation, link flowage, and all of the web links are functional and not redirecting. Those are good first steps for functional testing. So one of the key things that I said was separate tests for functionality. So you need to perform like link testing, form testing, cookie testing. They all need to be separate. And you need to be specific on the elements of the website you are testing. Be thorough. Because when you don't have a plan, you may jump around more and more, and that normally leads to areas of improper testing. So the big 6 that we're looking at are link testing, form testing, cookie testing, documentation testing, scripting testing, and HTML or CSS testing. All of those encompass the website testing. So link testing. This is basically where you plan to test all the links on the site. Outbound, off-site links, internal links. You want to make sure there's no missing or omitted links, email links, or even broken links. There's a variety of broken link checkers that are out there, and here's a list of a few. But the big thing here is making sure that you at least check. Form testing. This is where web page forms have primary types of data that might be missing or unverified. Is there missing data? Is there input validation? Are standards set for values? Are there abandoned shopping carts, and how is that handled? So are there pull down lists? Are there other fixing portions that might be there? You need to look at how the organization or the function of the site as a whole actually is handled. If we mouse over something and we actually click on something, is the key message of the organization present? Are you able to do like an about, but are you able to click on the about? Things like that. You have to test. Then we have to do cookie testing. This is testing for the creation, the presence, or content of a website cookie that will verify the functions are working correctly as they should. Each time a visitor downloads the website either creates a cookie, if none exists, or reads a cookie and creates a UX. Website cookies are stored on the client side, and there's 2 main types of client-side cookies: session cookies and persistent cookies. Session cookies will track the interaction of a website and a visitor, but only for a single specific user. A persistent cookie will hold, at least at minimum, 3 pieces of data. They identify the server, the initiated cookie, the lifetime of the cookie, and a randomly generated value that serves as an identifier to add a certain level of protection. Some browsers, like Mozilla, do have the ability to manage cookies and data sites, and this is an example of a managed cookie and data site pop-up from Firefox, essentially. To view the developer tool options in Chrome browser, you should also look at showing cookies associated with the website, so you could do the development tool. Again, almost every current web browser has development tools built in, so you have some options while doing that. To fully test the cookie-related functions of a website, you can use any of the 5 separate testing methodologies. You can disable and remove cookies, then exercise the site's cookie-related functions. You can open and edit a cookie in a text editor, randomly changing its values and saving and testing. You can test the website and its use of cookies with multiple browsers. After closing the browser, verify that all session cookies have been removed. Or persistent cookies, are they created and sent to a client from the website's service side function? If the user credentials included the username and password, credit card number, and things like that are included in the cookie, you could see if that's even present. Is it protected? Is it secured? Is it encrypted? So again, you need to be testing these common things to ensure basic function of cookies are performing as expected. After we have that, we have our validation testing. Normally here we're looking at HTML and CSS validation. This is looking for small errors in the code because small errors can cause big problems. Missing closing parentheses could cause an important action to be omitted. Typing the wrong CSS code may emphasize the wrong heading or action. Numerous tools can check the code, but a run-through of common function of the HTML and a general review of what a person would actually be doing is a great test. So sample result web page for a website tester, you'd run through it. The website tester, like this one, will check the variety of content function for problems, server behaviors, internal or outbound links, meta tags, and so much more. That way, they can see what's going on and if there are any weird oddities. You might also have a SEO testing program, and that's going to search for quality, structure, server response, external factors, so that you can see an SEO score that may increase or decrease your capability of being found on search engines. After that, we have general security testing. Testing the appropriate types should be kind of important because every phase of a web app development needs a pre-release testing, and that should include security. Security flaws or vulnerabilities should be corrected or mitigated before moving to the next phase, and definitely before testing and before the testing phase. It needs to be tested almost every phase. And again, it needs to be performed over and over and over from its beginning all the way to the end to ensure that there are no major flaws or protections that need to be mitigated. Website security functions are generally limited to protecting the integrity of PII and sensitive data that might be stored by the site. It should be protected and encrypted, but again, it's kind of subjective. It really just depends on what's going on. Testing the security is a matter of exercising the entire data flow of the website by entering all data a user is requested to enter, including data to be secured, and then verify that it's actually protected and secured. Big thing here is you want to act like a regular user and check and verify. Any security flaws that you find, you need to mitigate. So mitigating the website security flaws are critical. So when you're assessing the vulnerabilities of a website or web app, keep that in mind, that the search for vulnerabilities could exploit is not just inventory, but it's more like an investigation. You want to poke, want to probe, you want to investigate all function of the site. The mitigation process should be removing or limiting the exposure of the vulnerability to a threat so that an attacker may not be able to actually exploit it. Once a website vulnerability is found, the decision needs to be made. Is it truly a threat that can cause harm to the operation, content, or security of the site? What's the potential cost for the repair? What is the risk for exposure? Is it worth actually doing anything, or can we say that it's an acceptable risk to leave as is? One of the big things that you have to think about is once a flaw is found, the decisions need to be made according to the organizational policies. Sometimes, what strategy is going to be used? Is it accepting the vulnerability? Is it avoiding Is it to reduce or transfer the responsibility? These are all basic risk mitigation. So to mitigate a vulnerability or another security flaw, you need to take at least these common general steps. 1. Identify and verify vulnerabilities. Analyze, prioritize the vulnerabilities. Develop a mitigation plan, retest, and then ensure that it actually does what the expected outcome was. If you plan to transfer the risk and you go through the vulnerabilities, did it actually get transferred? Are there mechanisms there that add that layer of protection? Mobile devices. Website design specifically for mobile devices are going to be using codes like the extensive hypertext markup language for mobile profile, XHTML. And there's also some basic standards for CSS there as well. So it is actually technically XHTML MP, and it's very similar to HTML and XHTML standards. But the MP mobile profile allows similar testing to be done like regular HTML code, but again, it's more mobile focused. Some tests are specific to the website and some tests are specific to the mobile devices. So compatibility with various smartphones, tablets, things like that. Load time. My favorite is going to be object size. Phones and tablets come in different sizes. Do the apps, do the content, do the websites auto-scale? I deal with a vendor now whose website is not mobile friendly, and it is so frustrating working with them because I have to use their site, but it's not mobile friendly, and oftentimes I have to use it using my mobile device, and it just makes things that much more complicated. Image size. Are they the correct image size? Do they scale based off of the screen size? Are there bulleted lists? Are there short texts? Are there paragraphs? Do the data or the wording scale? Dial out function, which is compatible with mobile devices, and test and verify. Make sure it actually is compatible. Alright, as we move past mobile device testing, then we need to have the documentation testing. Help, facts, blogs. Are there an ADA or an assistant request form? Things like that. Are the original specifications, design requirements, function descriptors, front end, back end, are they verified? Is there good documentation? Is the data flow accurate? Websites will require thorough documentation from admin, developers, and users. Is there a change management for standardizing approaching for handling fixes, changes, enhancements, or modifications? So documentation is going to be kind of important, though that's one area that we oftentimes fail at. Releasing the website to the world. There is going to be at one point, you do all your testing, all your verifying, and then you go, okay, let's put this out there. After ensuring the data website is fully functional, error-free, secure, overall meets the functionality, you can put it out there. Several verbs are used to describe the action, but essentially, it's available. You may go through one last pre-launch task, inspecting and testing all content, correcting errors, misspellings, mistakes, check that media on the website are all displaying correctly, check the content concerning the company, the branding, the purpose, verify the use of permissions and licensing, test or retest compatibility. So a month or two before the launch, maybe start marketing and building the demand for the content. After that, you have your website launch and diagnostics. When the website is ready to launch, verify you're able to connect and interact with the world from the web server. The website that fails to work should cause the visitors never to return. So you want to be careful here. If you're an e-commerce website, You may want to convert every visitor into repeat buyers, but major retailers may have a conversion rate of like 2.5%. That means for every 100 visitors, only 2.5% actually buy something. Like Amazon. Amazon is not having every visitor buy something. They're in the 2 to 5% mark. After that, we have our diagnostics. Is the website performing the way it should? Immediately before the launch, run an analysis and diagnostic tests. After the launch, repeat, compare the baselines. Diagnostic checks are only for static issues like the site, such as broken inbound and outbound links, error in code, unreachable objects, and more. And I normally do the testing diagnostics before and after the launch. That way I could see if there's a specific dead area. Is there an inbound link that's not working? If a specific page that I think should be used more, if it's not, I can start checking to see what's happening. After that, we have our SEO strategy, and that means getting our SEO up, so ranking high and being able to be listed on the first page of a search engine is a goal of commonly every website out there. So to help position a website for search results, use a set of keywords, experiment with different keywords, and some pages of websites may appear higher or lower in the search engine results, perhaps even higher than your landing page. You need to figure out why and make the SEO strategy a little bit more compelling for your main landing page. Here is a website diagnostic package display for Google Diagnostics, and you can look at visitors versus returning versus sources. Here is a post-launch diagnostics. This is checking for broken links, analyzing SEO strategies, and different things like that. Google has a lot of their tools out there, like developer.google.com, analytics. This is one of the great tools that is provided. Again, this is not an exhaustive list. This is just common ones, but there are definitely more out there. Just have to do some searching. Alright, that is the end of this chapter. Questions, thoughts, or concerns, please feel free to reach out. Thank you. Alright, that concludes this video lecture for this chapter. If there's any questions, thoughts, concerns, or issues, please don't hesitate. Feel free to reach out. Thank you.